Hello, we're Team TurtleBox, and my name is Joseph Lee, and my other group members are Taeyong Chan, Junhyuk Park, Hee-Sung Yang, and Jonathan Lee. So, this is our team. Our team TurtleBox is a group of students trying to use the CubeSat for greater use. We all volunteer at local beaches by picking up trash, which helps keep our community clean. With the use of the CubeSat, we can detect trash on surfaces of the ocean that will help not only nearby communities, but communities all around the world. This is a big step in helping create a cleaner and healthier world.
Hello. The smart requirements for the CubeSat are the CubeSat shall be able to power on, which we're going to verify through demonstration and test. The CubeSat's components shall be within the structural frame volume, which we're going to verify through inspection. The CubeSat shall be able to capture images, which we're going to verify through tests. The CubeSat shall be able to identify colored plastics from processed images, which we're going to verify through demonstration and test. The CubeSat shall send data to the ground station, which we are going to verify through tests. The ground station shall receive data from the CubeSat, which we are going to verify from the test. The CubeSat shall be able to continuously run and recharge, which we're going to verify through demonstrating and test. The frame of the CubeSat shall fit in a 10 centimeter by 10 centimeter by 10 centimeter cube, which we're going to verify through inspection. The CubeSat's calculated position of the plastic shall match the actual position of the plastic, which we're going to verify through analysis and test. The concept of operation is that we are going to turn the power on the CubeSat, and we are going to prepare for like the pre-launch. And if the pre-launch doesn't work, then we're going to check out and go to self-tests to fix the problems. And if the self-test fails, we have to restart over again. But if the self-test works, we're gonna go to the launching phase, and after we launch it, we're gonna deploy it into orbit insertion. And after that, we're going to start the self-test again when it's up in the orbit. And if the self-test doesn't work, then we're going to go to the error contingency. And if the contingency doesn't work, then the CubeSat failed. But if the self-test works, then we will move on to the on orbit and on station phase. And if the on orbit and on station phase does not work, then we have to go back to self-test to fix the problems and move back on to on orbit and on station. And after that, we're gonna signal the camera to turn it on. And if it doesn't work, then the CubeSat failed. But if the CubeSat turns on the camera, then it's gonna take a picture of the ocean. And if the CubeSat takes a picture of the ocean, it's gonna figure out which items are trash on the ocean, and after that, it's gonna send back the plastic information to the ground station. But if the TurtleBox or the CubeSat can't take a picture of the ocean, then or can't figure out which items are trash on the ocean, then it's gonna have to take another picture of the ocean to figure out which items are trash on the ocean, and then send back the plastic information to the ground station. So the science operation is that once the CubeSat is on the rocket and it's sent to the space, it's gonna go to it's gonna orbit around Earth, and once that happens, the radars are gonna send a signal to the CubeSat to take a picture of the ocean, and when the CubeSat sends back the information, the radar will send the information to computers to the ground station to store the information. And when each time the CubeSat goes to a new state, the radar is going to send signals to the CubeSat to take a picture of the seas, to take pictures of the sea and detect the trash. And then the CubeSat will send back the information back to the radar for each state. So it's going to be like a loop.
This is the cap model for our CubeSat. The blue panel on the top is the solar panel, which is the energy source for the CubeSat. The black circle is the camera, which is the object detection module. The Raspberry Pi board or the processing system is located in the center of the CubeSat, which is shown as a green rectangle. The IMU sensor is a yellow rectangle next to the Raspberry Pi, which finds out the position of the CubeSat. The black box on the bottom of the CubeSat is the battery, which is the energy storage. The Acro panel or the case serves as a protection for the hardware components of the CubeSat.
Raspberry Pi outputs the image to display by HDMI port and deliver command to IMU unit through 40-pin extended GPIO. And the IMU unit delivers IMU data to Raspberry Pi through 40-pin extended GPIO. The Raspberry Pi also delivers command to camera through camera port, and the camera delivers image data to the processor by camera port. The solar panel delivers power to the battery, which is delivered to the processor eventually through USB-C port.
The mass budget bill of materials and tools have 26 kinds of materials listed, from things like the Raspberry Pi and micro mass cards, SD cards, to F&F jumper wires and 40L brackets. With a total of 345.3 tools, we have found that there is 1,014 grams in total with contingency.
The solar panel we were given produces only 0.231 watts per hour, and the sunlight is very strong. But when Raspberry Pi is idle, it uses 2.7 watts and 6.2523 watts per hour when it's processing. So we need a solar panel that is at least 27 times bigger than the one we have given in order to make Raspberry Pi work properly with charging. And here are the power components. So we have Raspberry Pi, IMU sensor, and camera.
Our algorithm first works by taking a large picture of the ocean and differentiating We configured our software architecture to detect objects on the sea, figuring out whether it is either plastic trash or ships. Our algorithm first works by taking a large picture of the ocean and pointing out objects by different colors and sizes. After we have a distinct separation between the trash and ships, the information will transmit information about the size, shape, color, and position of the trash to the ground station.
Our team had calculated the link budget of the link between CubeSat and the ground station. We have the frequency, orbit, bandwidth, ground station antenna gains, and satellite antenna gain. From those parameters, we've calculated different budget data for the uplink transmit channel and uplink receive, noise, and downlink budgets. And from this data, we've calculated the capacity of the channel in two conditions. When the CubeSat is directly above the ground station, 400 kilometers in this case, the data rate is 4.4 megabytes per second. Moreover, when the CubeSat is not directly above the ground station, which is 700 kilometers away, the data rate is 4.1 megabytes per second. The pixel depth of the image file that the CubeSat will send is 24-bit, which is 3 byte. The dimension of the image is 3280 pixel by 2464 pixel. The size of the image file will be 24.2 megabytes and 2.42 megabytes after the image compression. Also, since the link communication data rate is 4.4 megabit per second, it will take 4.4 seconds to transmit one image file to the ground station.
So finally, I'll be talking about the integration and test plan. So first, we will print out a picture of the sea with identifiable plastics as a color range to detect what part of the picture that is the ocean and what part is the plastic. Then we will have the CubeSat take pictures from a certain height, and if there are places in the picture that does not match the color range of the ocean, then it will record its size, shape, and position and on the picture. These colors will then be determined if the color is a plastic by using differential equation and color information described in software architecture. Some future modifications we have is a wireless communication. As of now, we don't have this wireless communication module on our CubeSat, but if we were to add this, we can actually send information and data to the ground station. This data could contain latitude and longitude of the position of the plastics, and size, color, shape, and also the captured image by the CubeSat.
My name is Jonathan.
I'm Junhyuk.
I'm Hisong.
I'm Joseph.
I'm Teddy.
We
are Team TurtleBox, and thank you for watching.